Hey everyone, this is Mr. Leclerc again. This time we're going to be looking at problem C on page 42. Tangent of t equals 1. Okay, so remember what that means. It means that for what angle does tangent equal 1? This problem is going to be a little bit more challenging than the last two because we need to remember what tangent means. The definition of tangent, which can be found on your unit circle on page 34, is right here. So tangent equals sine divided by cosine, or the y-coordinate divided by the x-coordinate. Okay. So what does tangent t equals 1 tell us? So tangent being 1 tells us a few things. First, in order for two numbers divided by each other to equal 1, they need to be the same number, because some number divided by itself is equal to 1. But that won't happen any other way. So we know at least that sine and cosine, or the y-coordinate and the x-coordinate, are the same number. And that only happens in a few different places of the unit circle. Notice also that tangent is positive 1. So that tells us that we need to get positive 1 by dividing two of the same numbers. And that can happen in a few ways. Let's remember how. So if we have some x divided by y-coordinate equals 1. That can happen if both x and y are positive. That can also happen if both x over y are negative, because a negative divided by a negative is also 1, positive 1. So that tells us that cosine and sine, or our x and y, needs to be the same, and they either have to both be positive or they have to both be negative. So let's look at the unit circle and see where that happens. Let's first look for both of them being positive. So on the unit circle, if we know that x and y are both positive, we know we're in quadrant 1, because x and y are both positive only in quadrant 1. Now we need to look for sine and cosine, or x and y coordinates, being the same. So let's see, at 0 degrees, we have 1 and 0, those are definitely not the same. 30 degrees, we have square root of 3 over 2 and 1/2, those are not the same. At 45 degrees, we have square root of 2 over 2 and square root of 2 over 2. So in this case, x and y are both equal to each other. So that tells us that tangent can be 45 degrees or pi over 4 radians. Same thing. So let's go ahead and write that as t. So t equals 45 degrees or pi over 4 radians. Okay. Now we need to find the other value for t. So we need both x and y to be negative. Go ahead and pause the video. Try to find on the unit circle where tangent might be 1 and x and y are both negative. Okay, so let's come back. So x and y are both negative in quadrant 3. And only in quadrant 3. So we know that our angle is somewhere in here. Now we need x and y to be the same, or cosine and sine to be the same. That only happens right here. And they're both negative. We have negative square root of 2 and negative square root of 2 over 2. Because if we divide those two numbers, we get 1. So then t is 225 degrees, or 5 pi over 4 radians. So t is 225 degrees, or 5 pi over 4 radians, same thing. Perfect. So that tells us at 45 degrees, or pi over 4 radians, tangent is 1. And at 225 degrees, or 5 pi over 4 radians, tangent is 1. Now we need to find the reference triangles. Okay. So just like before, if we want to find the reference triangle for 45 degrees, we need to connect our terminal side to our initial side, or our x-axis. Our terminal side at 45 degrees is right here. We connect that to our x-axis, or our initial side, and there's our first reference triangle for 45 degrees. I'll go ahead and sketch that on page 42. There's our reference triangle for 45 degrees. Okay, now pause the video and try to find the reference triangle for 225 degrees. Okay, let's come back. So we should have drawn the reference triangle at 225 degrees by connecting our terminal side at 225 to our x-axis, or our initial side. And there's our second reference triangle for 225 degrees. I'll go ahead and sketch that on page 42. And there we have it. Perfect. So we found both of our reference triangles for 45 degrees and 225 degrees. And we found that tangent can be 45 degrees, or pi over 4 radians, and tangent can be 225 degrees, or 5 pi over 4 radians. In the next video, I'll go over problem D. But you only need to watch the next video if you're planning on going to calculus next year. If you're not planning on going to calculus next year, you can stop here. If you are, I'll see you in the next video.